Hello, everyone. Welcome. My name is Daniel Moyer. I'm a sales support trainer here at Briggs & Stratton Energy Solutions. As we're getting started here, a few people are still trickling in, but I want to introduce Nathan Hessen. Good morning, good afternoon, good evening, Nathan.
Hey, good morning, Daniel.
Nice. What we have for you guys today is ESS and environmental considerations. Really, we're coming into winter. It is winter, going to be here soon officially. We're still fall. We haven't had the solstice yet, but we thought it was very apt to be talking about this right now as we're coming into kind of the winter season. So this presentation, we're going to talk a little bit about who we are, some of the market drivers and growth, our products, of course. But really what we're going to focus on is cold weather applications. We're also going to jump into a little bit about humidity, altitude, and vibration, show you some case studies, and then talk a little bit about our IQ qualification program at the end. So if you do have any questions during the chat or during this talk, please put them into the Q&A. The chat has been disabled. So either at the top of your screen or the bottom of your screen, you're going to see a Q&A button. Go ahead and put a Q&A in there. And we'll go ahead and answer your questions either live during the talk, or Nathan, who's monitoring the Q&A, will get you your question answered. Additionally, this is a NABCEP accredited course. So we do have some credits available at the completion of this course. We'll check the logs and make sure that you attended the whole way through. At the end of this talk, we're going to have our training email is going to pop up, and you'll be able to email that email address. Let us know your name, your full name, and spell it out for us so we get it correct on your certificate. And then we'll go ahead and email you a certificate for the continuing education through NABCEP. Bringing up, you guys are all here to learn, so I'm excited about that. If any future training opportunities, go ahead and check out our Power Academy. There's a lot of great resources on Power Academy, briggsandstratton.com. /Power Academy. And then also keep an eye on our training calendar. We got a great training coming up, not next week, but the following week, off-grid living with SimpliPhi batteries. I'm really excited to be presenting that. So please register and log in for that. Additionally, as we're kind of joining here, and Nathan, I thought this might be fun, is we've done this in the past. If somebody wants to, who has the coldest ambient temperature today? And I'm not sure if Nathan's going to let me do this, but maybe we'll send you a sweater or at least a hat. So go ahead and put it into the Q&A. We're going to be on the honor system here. Maybe put the city you're in and the temperature, the projected low temperature that you have here. And whoever gets the coldest temperature, maybe we'll get a winner. Maybe whoever has the warmest ambient will get the hat, and the sweater will go to the cold one. Really quickly, I want to just introduce ourselves. Briggs & Stratton Energy Solutions is now a partnership of Briggs & Stratton, the company, this historic 115-year-old company that's been around for a long time, now combined with SimpliPhi Power, who's had a history of creating very high-quality batteries and energy storage systems. And combining these two companies together, we're now one complete integrated solutions provider. What that means really is that we provide both generators and energy storage as an all-in-one solution. And we do have other talks where we talk about how generators and energy storage can complement each other rather than compete with each other. So I'm really excited to be part of this great organization. I'm also excited to say these products are assembled and made in the United States. That allows us to have a great level of quality control, and also pivot and advance our technology as we're moving forward and advancing our technologies for the future.
So Daniel,
yes.
Just so far, we've only had one submission there for the coldest temperature. So please go ahead and look up your projected low temperature from your weather channel. Give us your coldest temperature at your location. And for the person that has the coldest temperature, we'll get some free Briggs & Stratton swag coming out, either a hat or a sweatshirt coming your way. So please go ahead and participate. And I just want to emphasize that we really like the questions coming in. Often many people benefit from those answers. So keep those questions coming in, and I'll interrupt Daniel with questions as we get into the meat of the material today.
Yeah, thank you, Nathan. And I think we benefit too, Nathan, right?
Oh, absolutely.
So I'm really excited. I also like NOAA. I think NOAA, that should be the gold standard for your cold temperature. So please look it up, put it in the chat. Intersolar's coming up, and talking about warm, it's going to be in San Diego, everyone. So I think the projected lows are going to be a lot warmer than maybe where you're at. Certainly for me up here in Northern California. Intersolar's coming up. We're going to have a great booth there. Please use that QR code you see on the screen to go ahead and register. I do know that NABCEP is giving free expo passes out. That's not a full conference pass, but if you go into scan this QR code or go to the intersolar.com or .us website, enter in the promo code NABCEP, NABCEP, and that should give you a free expo pass. Join us. Please let us know if you're going to come down to Intersolar. We'd love to see you and show you around our booth. Another exciting kind of recent event is we are now CPUC authorized for SGIP, Self-Generation Incentive Program here in California. So some of our products are available for some of these adders through the Self-Generation Incentive Program. This is really going to help us out in California, where the new NEM 3.0 has come into effect, which has really kind of affected the way that people have to position solar plus storage. And Josh Brum at Solagent has actually said that you should really brand it as storage plus solar. And really that you're going to need to add a storage system to any photovoltaic system in California to make sure that you get a financial return on that investment. And really, it gives you backup as well. So these are the participating utilities you see down there at the bottom of your screen. Really exciting. We have other resources and documents that can help you apply for this SGIP program, and email us and we'll be able to get you those documents or put you in touch with one of our experts who can help you run through.
Daniel, real quickly, CPUC, California Provided Utility.
California Public Utilities Commission.
Exactly. And the SGIP program is a rebate. What is this?
Yeah, it's a self-generation incentive program. So really, it's money, taxpayer money from the state that's being offered to people's systems to get them in the game if they're in, say, a disadvantaged community, as historically cold. There's a lot of different qualifications that you have. I'll let you know this, that we participated in this. And if you got a customer that's on a well pump, if you got a customer that's on a low income or lives in a fire zone or in a low income area, there's money available through this program, and our products qualify. Go ahead, Nathan.
I just wanted to quickly say this is a California incentive program, and we have many international as well as customers that are attending this webinar from across the US. So this is limited to California installations, right, Daniel?
That's right. But this brings up a good point, is that there are a lot of other types of these programs available in your state, in your country, perhaps. If you are here in the United States, there's a great website called Desire, DSIRE. Go ahead and it's a .org, right? So it's a nonprofit. Go ahead and put in your zip code, and it will pull up any of these other similar rebates like the SGIP program. Great point, Nathan. It's specific to California, but there's a lot of other programs around the country that are available.
Daniel, one more time, that website is Desire?
Yeah, Desire, without a DSIRE.org. Nathan, maybe if you want to put it in the chat or the Q&A so everybody can see that as well.
I will do that. And, just as a good example, Vermont is offering a $10,000 rebate from their utilities. And there are other rebates across the country for installing ESS systems. So
and that's not even including the 30% ITC, right? The 30% tax credit that's available through the feds, right? So that was a state program. There's lots of state programs. There's also federal money. And whenever I've talked to a customer and shown them that I'm saving them money, it really helps make the sale happen and helps you close the deal. So always do that research and do that homework before you're sitting down at the kitchen table with the customer, and show them that you've done your homework and that you've discovered some money for them. And we're going to go ahead and maybe even apply for them, and don't make the homeowner have to do all the paperwork. Let them know that you're going to do the paperwork for them. A lot of times they do have to kind of pay up front, and they'll get that money back later. But check out those programs. Check out your local programs. All right, here we are. We're looking at a battery here on our screen. SimpliPhi Power uses a cylindrical cell with a lithium ferro phosphate chemistry. There's other types of form factors, like pouch cells and prismatic cells. And there's been a lot of recent developments in those types of form factors, and the quality is getting a lot better. we're still on the cylindrical, and on the right-hand side, you're seeing kind of the cutaway of the different layers that you would see in a cylindrical cell. And Nathan, I'm going to call upon you here to help us walk it through it. So what happens in a lithium-ion cylindrical cell when it's charging or discharging? And then what happens when that battery cell gets cold? I think we might have lost Nathan, so I'm going to run us through it really quick.
Sorry about that, Daniel. I
Yeah.
was talking and didn't realize I had muted. I was typing in the desireusa.org is that website. I'll get that in the chat in just a second. I'm sorry about that, Daniel. So inside a lithium cell, you can see kind of a cutaway of the jelly roll inside a cylindrical cell that's at the center of the screen. So inside a cylindrical cell, we have the positive anode, or the negative anode, and the positive cathode. These are sheets, and what's between them is a material known as electrolyte. And of course, for a lithium-ion cell, what you have is the migration of those ions between the positive and the negative side. As we charge up those cells, those lithium ions move to the graphite anode, the negative side of the battery. And as we discharge, those lithium ions move back to the metal oxide, the positive side of the cell. And of course, as those lithium ions are moving back and forth, that's what causes the electrons to shift from the negative side of the battery to the positive side and either be running through our charger, or in a discharge cycle, we could replace that charger on the screen with a load. So when we get quite cold, what ends up happening is the electrolyte, which is a solvent for those lithium ions. When we get very cold, that electrolyte becomes very viscous. And so the movement of those lithium ions is restricted. Additionally, movement of those lithium ions in the charging process into the graphite material of the anode, a process called intercalation, gets slowed down. And so we have to charge at slower rates during very cold temperatures. And Daniel's going to talk to you a little bit later in this talk about some innovative solutions that our BMSs use in order to charge our batteries in really cold temperatures, temperatures in which other batteries typically are not able to charge.
Thank you, Nathan. So if I understand you correctly, right, if we're trying to charge at a very cold temperature, we can damage the battery. Is that right, Nathan?
Exactly. So the battery can be damaged from the formation, the buildup of solid lithium deposits, some things called dendrites, which can actually penetrate the porous separator layer that separates the anode, the negative side of the battery, the graphite, from the positive side of the battery, the cathode. And so if you charge rapidly, if you try to charge rapidly in really cold temperatures and repeatedly do this, we get the buildup of solid lithium in the form of dendrites, which can eventually damage the cells, reduce capacity of the battery, and even short them out in prolonged cold temperature charging. So we have to make sure that we are not trying to charge too rapidly in cold temperatures, and we'll get more into that. Yeah. Hopefully that was clear. We could spend a whole 10 minutes describing this exact process.
And I think it was good to spend a few minutes here, because really this is kind of the great takeaway of this talk. And what happens in this process isn't necessarily specific to SimpliPhi batteries. It affects all lithium-ion batteries. So it's really important that we have temperature considerations and not charge batteries below freezing. One thing is that what we're looking at here, and I'm going to maybe call upon Nathan here again, is we're looking at some batteries that essentially were submerged in a temperature-controlled oil bath, right? So that there is a good thermal regulation of a battery cell that's kept at the specific temperatures. And what you're looking at is a discharge curve, right? The resting voltage is essentially when you have a battery just sitting there, not being charged, not being discharged. And what you're looking at is the voltage versus the depth of discharge, right? So as we all know, a lithium-ion cell has a pretty flat curve, right? The difference between, say, 10% depth of discharge and 80% depth of discharge, really, I mean, 3.4 to 3.2 volts is a very small drop, but then you can see it kind of dropping off as it reaches either end of the curve. But what we're also seeing are those colorful looking curves there. And those are the discharge profiles of a battery that's kept at a different temperature. So Nathan, if you could just walk us quickly through what are the takeaways of this this right here?
Well, there are a couple of takeaways. So look on the bottom left of your screen where you can see that just a cyclic path that current flows. So in the process of discharging a cell, you have current flowing around in that image in just a clockwise fashion. And what ends up happening is you have charge moving out of the cell in the form of current, right? You have internal resistance inside the cells, inside the batteries, due to the connections, due to the electrolyte, the flow of the ions, etc. And so the more current you have passing through a resistor, the more voltage drop you actually have across the battery. Right now, your load also has a voltage drop across it, and the majority of your voltage drop should be across a load. So if we're discharging just a single cell and we're doing it at colder and colder temperatures, what you can see is that voltage drop out of that cell is more, right? And that has to do with the fact that that electrolyte becomes very viscous at cold temperatures. It's kind of like trying to pour molasses or some other liquid which has increased viscosity at low temperature. And so when you are discharging batteries in cold temperatures, what you see is that there's a greatly reduced voltage compared to the resting voltage. As soon as you stop discharging the battery, the voltage will jump back up to that resting voltage because you're not losing voltage due to current flow. So if you stop the current, that voltage will jump back up to the resting voltage. Now, a couple of takeaways here. This is data that is we've forced the cell to stay at cold temperatures. And additionally, a real cell would not stay at that temperature if you're discharging. If you're discharging fairly quickly, that internal resistance will cause the cell to heat up, and you'll see that cell warm up and switch between individual curves here. So in cold environments, it appears as though your battery, when it's discharging, is at a lower state of charge, or at least at a lower voltage than the same discharge rate at warmer temperatures. We can actually use this to help warm up the cells. So when those cells are discharging when they're cold, it will start to warm them up. And as they get warmer, we can discharge them faster. We can also heat those cells to prevent them from being on these reduced capacity curves. And by heating those cells, end up having access to a larger capacity. The capacity for the cell is the area under the curve. Now, keep in mind, this curve bottoms out at 2.4 volts. We don't bottom out at 0. So, but there is a slightly diminished capacity to batteries when operating at very low temperatures.
That's the great takeaway there. I love that analogy of the molasses slowly pouring as well. And you're right, we're not going to have our batteries submerged in a cooled oil bath. So like you said, if they're not in a cooled oil bath like this is demonstrating in this experiment, they're going to warm up on their own. Thank you, Nathan, for mentioning that. So one of the things Nathan kind of alluded to a little bit is that we can have a very innovative way of warming up our batteries. And essentially what that means is that if we have a battery that can communicate, like our SimpliPhi battery, it has built-in thermistors inside the battery pack. The thermistors are embedded between the cells, and the battery management system, the little computer inside every one of these batteries, can actually transmit what the temperature is, or more accurately, what the appropriate charge rate would be to not damage that battery. So if you are going to be in a cold weather solution and you do have a piece of equipment that can listen to one of our communicating batteries, our inverter, the SimpliPhi 6K, or a solar converter as well, go ahead and leverage that SimpliPhi battery because it can transmit what's an appropriate charge rate. And this is the chart here. As the temperatures, ambient temperatures, get lower, and really we need to make the distinction between what is ambient temperature and what may be the internal temperature of the battery is different. But as the internal temperature of the battery gets reduced, the battery knows that, and it can then transmit to the inverter, to the charge controller, whatever may be the charging source. Look, I'm too cold. I want you to start to charge me at a slower rate. And at some point when it gets too cold, below 20 degrees Celsius, it's going to stop charging completely. And that might be an opportunity for us to leverage some of our heating solutions, active heating solutions, which we'll talk about here in a minute. So really, it's a very innovative way that is able to allow these batteries to be used in cold weather environments without the need for an external heating pad or heating source, and still keep itself safe and still prevent itself from damaging itself as well. One nice thing also is a lot of these people use these in kind of their winter or summer cabins, and in the winter they're not at the cabin. So if you do have a battery at the winter cabin, what I'd like to see you do is the summer cabin is charge up the batteries, get them a full charge in fall before you leave for winter, and then let the battery sit, turn off all of the inverters, turn off all of the other devices, right? Because an inverter might have a parasitic load that could draw down on the batteries. Turn them off. The batteries all have a breaker built into them, so you can turn them off individually. Batteries are allowed to sit there at a non-charging state, a non-discharging state for quite a long time and not damage themselves. When you do come back in spring and you're looking to use this system again, go ahead and make sure you get a full charge on the system before you start to apply loads. And just keep in mind that you might need to do a couple full charge cycles and discharge cycles to really see that complete capacity of the battery return as well. The battery I mentioned earlier, which is the SimpliPhi battery, has those closed loop communications. The Phi battery, which is what you see here on your screen, does not have that closed loop communication capabilities. It still has a battery management system, but if you are going to be leveraging the Phi battery, and it's a great battery, it's not like it's anything less than a SimpliPhi, but if you have, say, an old Xantrex or an old Outback or some old pieces of equipment that don't have that capability to communicate, go ahead and use the Phi battery. And there's other opportunities that we can use to make sure we're not charging the battery below freezing, like these heating pads we're going to talk about in a minute, and other third-party devices as well. This battery is a workhorse, and it's a great drop-in lead-acid battery replacement for a system that has some old Trojan T105s or some old Deca batteries, MK batteries. You can drop this battery in and make it a great lead-acid battery replacement. Of course, the SimpliPhi battery, you can see the little communication ports up top, does have the ability and the added controls and intelligence in the battery to provide that extra protection and greater flexibility. Really, there's two layers of this. It's going to, one, tell the piece of equipment that I need to see a slower charge rate, I'm too cold. And for whatever reason, if that piece of equipment doesn't listen or doesn't curtail its charge, this battery, and it gets cold enough, this battery will go into a protective state as well. It's that smart. We're talking about outdoor environmental considerations. We do have some outdoor rated cabinets. What you're seeing on the left-hand side in the middle are our Boss 6 and our Boss 12 cabinets that can hold up to either 6 or 12 batteries. These are great for installations. It makes it really simple. You can get these bus bars and they have the terminal blocks. It's a NEMA 3R rated outdoor enclosure, and you could go ahead and set it outside. On the right-hand side, what you're looking at is our access cabinet. It's essentially the Boss 12 cabinet, but we took out 6 of the batteries and we put in a Solarc, in this example, a Solarc 12K, but we can also put in our 6K inverter in here as well. And as we're kind of looking at that picture on the right, think about this, that inverter, whether it's the Solarc or the SimpliPhi inverter, is going to generate some heat. So we're going to talk about this again in a minute, but just because your ambient temperature might be at a certain temperature doesn't mean the temperature inside that battery cabinet is going to be that temperature. It's going to be warmer because of the internal components generating heat. Additionally, inside of that battery itself, because of the internal resistance that Nathan had previously mentioned, that's going to be warmer still. So we don't want to start to consider these temperature considerations. Just because it's one temperature outside doesn't mean that's what it's going to be on the inside. And you can even additionally add insulation to that cabinet as well to prevent more heat loss. We'll look at that here in a minute. Really, I already kind of mentioned this, but as we're looking at that picture on the right, a couple things come to mind is one, that's a nice insulated shack, right? Battery, power cabin, whatever you call it. So that's going to also contain some heat and trap some heat in that. And really look at those solar modules. Those solar modules are tilted up pretty high. So we're definitely looking at somewhere at a very high latitude, either probably in the northern hemisphere or very south in the southern hemisphere. And that's an indication, right, that this is the dead of winter, and we got these solar panels kicked up at a very high degree to capture some of that sun that's just going to skirt along the horizon during this day. So again, if you expose these things to cold temperatures without design considerations, you're going to lose capacity. You might reduce your cycle life as well. And really, if you really hammer on them when it's cold, you're really going to damage the battery potentially at cold temperatures. Any questions yet, Nathan? Or do we have any people chiming in on temperatures yet here, Nathan?
We've got a number of submissions. So yes, I just emailed them on cold temperatures. So I do want you to know that we've got a couple of winners here for cold temperature, and we'll get some sweatshirts out to them. I was verifying the temperatures. Additionally, Daniel, I have a question here. Can you explain that amplified charge rate reduction? What specifically does that mean? Will the battery do that itself, or does the battery tell the charging and discharging equipment to do that? What are we looking at on the screen?
Yeah, so what happens is a lot of these, it's not like the old school days where you had these separate components that didn't really communicate or talk to each other. Say you have an inverter and it's charging at, say, 100 amps with a bank of batteries. Well, if the batteries recognize that they're getting cold and they recognize that the 100 amps is not acceptable, what they can do is essentially reprogram the charger. A lot of inverters have a charger and inverter built in, potentially even a charge controller built in. They will tell that piece of equipment, the ESS inverter system, the hybrid inverter, that I'm too cold and don't charge this battery bank at 100 amps, charge at, say, 25 amps. And the battery tells the piece of equipment, it reprograms the piece of equipment to reduce its charge rate. And as the batteries start to warm up, the battery management system will then reprogram the inverter again to allow that full charge rate to continue and resume normal operation. So it's not that the batteries themselves will limit the amount of current coming in. It will tell the piece of equipment that it's what to do and reduce that rate. Although I will mention this, that at some point the batteries can limit the current coming in by completely disconnecting themselves or opening up that contactor. Let me know if I didn't get that correct, and we can break that out a little bit more.
No, that's a great point, Daniel. But I guess in order for you to take advantage of the charge rate reduction or the charging rate incremental increase, we do need appropriate communicating equipment, which would be a Solarc branded inverter or a Briggs & Stratton branded inverter.
Yes, thank you. Insulation can also be a tool to mitigate the effects, right? So when we're thinking about insulation, I'm thinking about, conduction, heat loss through conduction, convection, and what's the other one, Nathan?
Radiation, Daniel.
Radiation, yeah.
So conduction, convection, and radiation. And by far away, the major heat loss out of batteries is going to be conduction, especially through a metal-cased battery. A nice example of this that I've often done in classes before, physics classes before with students, is to just take an ice cube and set it on a counter, and take an ice cube and set it on a piece of extruded insulation, like Daniel's showing there. So that looks like extruded, it might be polystyrene, but basically set an ice cube on a piece of insulation, set an ice cube on a counter, and you'll see that ice cube on the counter rapidly melt, and it'll sit on a piece of insulation for 20 minutes while it's very slowly melting with contact with air. So what you're showing on the screen, just laying a piece of insulation underneath the batteries, is a very good way to prevent cooling of those batteries during a cold nighttime.
Yeah, exactly. So that ice cube is not losing its heat to that kind of countertop that has some heat absorbed into it. So that's conduction, right? Convection would be, don't turn on the vent fans in the cabinet when it's cold outside. Don't be bringing in that cold air. Radiation, for example, would be, don't put a metal cabinet out in the middle of a field, and you're going to get that nighttime radiation loss. If it was in a covered or something that was over the top of it, it's going to prevent that radiation loss. So like Nathan said, if you got a battery sitting on a cold shelf inside a cabinet, you're going to lose heat through it. So if it does, you are working in one of these extreme conditions, and I'm excited to hear about some of the cold weather temperatures. What you can do is leverage our heating pads. And these are special order from the factory. What we do is we insert, you can see another thermostatic sensor that is inserted within the battery. What you do is you take one of our heating pads, and what we're showing here on the picture on the right is we found that by putting the heating pad on the bottom of the battery, and then when you put it into one of our battery shelves, the battery's kind of sitting vertical on its side, that by having the heating pad on the kind of the backs at the bottom of the battery, that the heat is going to dissipate or into the battery much more evenly, just due to the way the cells are packed inside that battery. If you had the heating pad on the bottom of the shelf on the side of the battery, we wouldn't get that even heat distribution that's as effective. So what we do is we kind of adhere that heating pad to the bottom. These batteries warming pads do require AC, and there's a complete kind of white paper on how to install this and how it works. I guess the takeaway here is do think about that heating pad as an additional load to the system. So it is going to add, you're going to have to add some modules. You're going to have to maybe add some batteries to allow or to compensate for that additional power draw by these battery warmer pads. They're 75 watts, but they're not on constantly, right? They're going to cycle on and off. Like with the thermostat, and there'll be a differential in there. So it's not going to be constantly on 75 watts 24/7. And really that's going to be a function of how cold the ambient temperature is, how well insulated the battery is from those outside temperatures. And then that'll kind of dictate what your consumption will be. And we have sales application engineers that have some examples, some numbers that you can use to work those through.
So please keep in mind that that is a special order item. So if you do want to have this cold temperature solution, if you do want to have those heating pads integrated into your batteries upon purchase, you'll have to let us know so that we can make those batteries in-house with that additional wiring capability. And as Daniel said, yes, it's a 75-watt heater, but it will be on only intermittently as needed to keep those batteries in the best operating temperature zones. Daniel, do have a question on the screen here. So Gail is asking, note using mineral wool products for insulation versus foams will offer fire-resistant insulation as well as not produce toxic fumes if a flame event should occur. And that is a good point as well. That's something to think about, right? These extruded polystyrene foams, and I'm blanking on the name. Extruded polyurethane is the even better thermal insulator, but those do offer, don't have fire protection like mineral wool or rock wool is another name for it.
Rock wool, absolutely. Great point.
Thanks, Gail.
Earlier, I had mentioned that if you have a battery, an amplified battery, it can tell a piece of equipment to curtail its charge so you don't damage the battery. If you have a Phi battery or any lithium-ion battery that can't tell a piece of equipment to curtail its charge, there are third-party devices. And what I'm showing you here is a charge controller from Victron. So what you do is next to the charge controller is a thermistor. And what you would do is you could essentially take that thermistor or thermocouple, whatever it may be, and sandwich it between the batteries. So although we're not reading the internal cell temperature of the battery, we're getting pretty close, right? We're able to kind of sandwich two batteries together, put this thermocouple between the two batteries, and then those wires run up to the charge controller. So the charge controller knows what the temperature is, and the charge controller itself can make the decision to curtail charge based on what it's reading itself. So these are great devices, and a lot of other companies kind of have these opportunities to curtail its charge rate by the device, the charging device itself, knowing what the temperature is as well.
So Daniel, those are good points. If you'll back up a couple slides, we have a couple of questions, and I'm afraid I don't know the answer to the first one. So Chris Schaefer says he'd like to see an optional external switch that would allow us to turn these heaters off or on. And he's asking if perhaps our engineering team can help us come up with this. I do know that there's in the wiring guide that these do have to be wired in. Do you know, Daniel, if there is a switch or the ability to at least unplug these heaters when they are not needed?
Yeah, there absolutely is. So what I'm not showing you kind of in the picture is there is a DIN rail that is mounted inside of the cabinet, and it has different, it kind of has a main breaker that you're going to feed your AC into. So it's kind of a DIN mounted breaker on the rail. So absolutely, you can turn on and off this AC breaker, and what that'll do is shut off power to all of the the heating pads, essentially. Yeah, and there's a couple other electronic devices in there, but absolutely there is a switch to turn that off. But really, you know, these are thermostatically controlled, so it should shut off. You know, really, I'd like to see you leave it on, because what I don't want to see is you forget to turn it back on when it is cold. But for whatever reason,
that's a good point, Daniel. These are thermostatically controlled, and they only turn on when temperature goes below a certain value inside the battery, right? So we're monitoring temperature inside the battery, and if that pack temperature is too cold, it will turn on. Andre also asks here, are the heating pads 75 watts per battery? And the answer is yes. So a 5 battery bank, yes, indeed, would be drawing 375 watts from the bank when that heating pad is active. Now, keep in mind, these are 3.8 kilowatt hour batteries, right? So 100 watt load, you know, is not a big, the battery would run for 38 hours on a 100 watt load. So these are only going to stay on long enough to keep those batteries, to warm those battery cell temperatures up to the optimal range, and then they will shut off automatically.
Exactly. Yeah, and they're also generating heat in that entire cabinet. So yeah, it's a great solution. Ideally, maybe these would be also located in the garage. You know, a lot of times if you're in a garage, you're going to have one wall that's shared with the home, and you might get heat leaking into that garage as well. Great questions. Keep them coming, everybody, please. Hot temperatures can be a concern as well. And there are, you know, I recognize we're coming into winter as well. Winter's coming. Sorry about that, but hot temperature can be a consideration. Nathan, what can happen to a lithium-ion battery when it gets too hot?
Well, under warm temperatures, first off, our batteries, our Amplify batteries, our SimpliPhi wall mount batteries, they will protect themselves if we get too high. So there are a couple of things that happen with the communicating batteries, and I think you're asking me what can happen with the cells themselves. But yes. First, with the communicating batteries, when the temperature exceeds 50 degrees Celsius, they will reduce their charge and discharge rates. But I think inside the cell, what you're referring to is if the batteries get very hot, if the internal parts of the cell get too hot, the electrolyte itself, which is an organic solvent, can actually turn to vapor, and with prolonged time and prolonged excessive temperatures, that can lead to bubbling in the jelly roll, which can delaminate the layers. And if it becomes extreme heat, that can even lead to increased pressure inside the cell, which can burst a safety vent at the top and release those gases so that the cell doesn't explode. So in extreme heat, if the battery is too hot and its temperature increases, eventually it can cause that vent to rupture. And that's what will happen if maybe, for instance, a car is on fire. Maybe it's gotten into an accident, the car catches on fire, those cells can open up to prevent explosions.
Yeah, and we replicate this. In fact, all the manufacturers replicate this in their UL 9540A large-scale fire testing. Like you said, in extreme situations, what happens when these batteries go into a off-gassing event, or even potentially a thermal runaway? Do they have self-propagation with unmitigated thermal runaway, or do they kind of just peter themselves out? And we're very proud of our results, and we publish them on our website, that not much happens with our batteries. Our
LFP cells, our lithium ferrophosphate cells, are much safer than the NMC cells, which are on the market. And so, yes, we do publish the tests that Daniel is speaking of, and we artificially induce extremely high temperatures inside the cells.
And that's a great point. A lot of the industry is moving away from the cobalt-based chemistry, the NMC, and moving towards the LFP because they recognize that that is a safer chemistry. And really, we've only ever leveraged that safer chemistry from our beginning. So really excited to be proud of what we've done with our cells and the safety record. Last kind of point on this side is just like in cold weather temperatures, recognize that just because ambient temperature is one temperature doesn't mean that temperature inside the cabinet or inside the battery itself is the same as well. I think Nathan and I are pretty close to the coast, and as we're talking about atmospheric moisture, really, what we're really concerned about is salt, and salt. Although a lot of these batteries are hermetically sealed, you can get salt kind of getting into the battery case itself, causing corrosion. So what we want to do is, if we're going to be in a marine environment or salt spray environment, try to keep them inside. Don't try to minimize the exposure as much as possible. I don't want to see a picture from Hawaii where it's sitting on some pieces of wood underneath the deck, half a mile from the ocean or something like that. Keep them inside, keep them in a cabinet, and keep them away from that condensing atmosphere as well. Altitude is an interesting one. And so when we're thinking about altitude, let's think about one is that for every foot in elevation you go up, temperature drops by a given amount. And so recognize that at a high altitude environment, it's going to be a lot colder. Also recognize that at a higher altitude, the pressure of the atmosphere, right? The amount of atmosphere that's above you is less than if you're down at, say, ground level. So the air pressure will be less, and that can pose a problem for certain types of form factors in batteries, specifically pouch cells, right? If you think about a cylindrical cell that we leverage, it has kind of a cylinder, right? A cylinder inherently has a lot of structural strength to it, just like a propane tank you could imagine. And so it can withstand pressure differentials better than, say, a pouch cell can. Additionally, there may be altitude limitations on other parts and pieces in the equipment. I'm thinking of the inverter as well, and you can see our inverter has a 4,000 meter limitation on that. So maybe we should do that next time we do this, Nathan, is who is sitting at the highest altitude right now. I'm probably about 200 feet above sea level.
Daniel, our boss has told us that she has plenty of swag in-house and would like to get rid of it. So I say go ahead and go for it right now. And I will say we have another question that's come in from Andre, and I think I know the answer, but I'd like to run it by you. Would a non-factory installed heating system jeopardize the warranty? I have a built-in insulated battery box that maintains 70 degrees Fahrenheit with dual heating system, a temperature-triggered incandescent light bulb, and a small fan that cycles between 68 and 72 degrees with a redundant backup heating pad set below the batteries that cycle between 45 and 68 degrees. And I think the answer to this, Andre, is that your warranty would stay intact, provided that this system doesn't malfunction and create a temperature inside that box in excess of 160 degrees.
Or fail and not generate the heat. I want to know where you
fail and go in, but separate cold weather protections are available as well. So if you are worried about that box failing, if you have AmpliPhi batteries, the AmpliPhi batteries should activate their own protection. And additionally, if you have Phi batteries, you want to make sure that your charging equipment does not charge in temperatures below 32 Fahrenheit. So I would say to add some backup on there, but no, you can use a temperature controlled environment. In fact, a lot of our installations include temperature controlled environments.
Yeah, no, it sounded like a great system. And I think he did mention a backup. I just want to know where he bought an incandescent light bulb at.
Great question.
That's a great one, but that is a great solution, right? Yeah, that's why we went to LEDs, right? That's why we went to compact fluorescence, is because an incandescent light bulb, if it's 75 watts, Nathan would probably have a better guess than mine. How many watts is being turned into visible light, and how much is being turned into heat? Maybe half and half. So
that's an easy question to answer, Daniel. If we look at a 75 watt equivalent from an LED bulb, you're looking at about 7 or 8 watts. So it's about 90% heat. You know, about somewhere around 10% or less of light with an incandescent bulb. And hence that's why these 100-watt light bulbs can now be replaced by 5-watt LED bulbs.
Yeah, equivalent, right? So they would have to have the same
They
amount of
produce the same amount of
lumens,
light.
same amount
They
of
don't
light
produce
lumens.
this, they don't consume the same amount of energy. Exactly.
Yes. So I love it. Just put a light bulb in your battery box, everybody, if you can find one. Not quite that simple. You'd want it on thermostat, but great question. I love it. Let's keep moving on. We're kind of getting to the end here, everyone. Vibration. So I've always been excited about how many systems I see that look amazing in these Sprinter vans, these Ford Transit vans, these Airstreams. I live in Arcata, California, which is on the kind of the northern coast of California, right on the Highway 101. Nathan's down in San Luis Obispo on the 101. So I don't know about you, Nathan, but I get a lot of people traveling through with these amazing looking vans and camper vans, and they want nice, reliable energy storage systems. And Victron makes a great kind of suite of products that I've seen leveraged in a lot of mobile applications. Our batteries, you know, although not tested for this exact application, have had a lot of success, and there's opportunities to use our batteries, perhaps put the batteries in such a position that they're not being jostled around as much, maybe over the axle, or put some foam underneath rock wool, right? Because we want to keep it safe and kind of insulate it from vibration. But it's definitely a situation that can work. Lithium ion batteries are very energy dense, very lightweight compared to lead acid batteries. So if you imagine you're traveling down the road, you want to reduce the weight and the vehicle and the trailer as much as possible. Let's look through some examples. This is a great system here in Montana. What do we see? We see some insulation, right? We see an insulated box. This looks like 2 or 3 inch foam, and the batteries are kind of put in there. You know it's cold, right? You can look at the picture on the right with that it looks like a black bear there. Again, a pole mount. This looks like this pole mount is tilted a little less steep than that first pole mount we had looked at earlier. So they're probably maybe in a summertime, or maybe that's not adjustable, and they've found a happy medium between the winter and the summer sun there. All that Schneider equipment is definitely going to be producing heat in that structure as well. So this is what it can look like. Go ahead, Nathan.
Daniel, great. Can you go back one slide? I think that this is also a great point to be made here. So one, batteries themselves do produce some heat, and that's what we were discussing earlier in this talk. So simply keeping that heat in, having an insulated cabinet like this, if you know you're in some place where the batteries are not going to overheat, you know, you might want to remove this lid during the summer, but keep it on during the winter. Simply maintaining the heat that those batteries release upon charging and discharging. So when you're looking at a charge cycle, depending on the temperature of the batteries, anywhere between 2 and 5% of that energy can end up as heat. I guess I should say 1, because at higher temperatures, there's very low internal resistance. But maintaining that heat by just keeping it inside an insulated cabinet, what you're looking at is 2-inch extruded polystyrene foam. This is easily sourced at most of the big box or the home supply stores. So if you're in a cold environment like this during the winter months, maybe just keep those batteries inside an insulated box.
Yeah, and I noticed in the kind of the center right picture that there's a thermometer up there too. So this homeowner is keeping a good eye on their off-grid system. All of our batteries are warranted for off-grid. It's where a lot of times we got our start in the industry. A lot of our competitors don't warranty for off-grid, so we're able to leverage off-grid, and our batteries are inverter agnostic. You see it paired right here with this Schneider XW Pro, I think it is right here. So we have integration guides available that will tell you how to program that XW in such a way that treats those batteries the way they want to be treated. The float voltage, the bulk voltage, disable the equalize, the charge, the discharge rates as well. So again, we are have our roots in off-grid, and it's somewhere where we can still offer you a solution as well. Off-grid in Alaska, these Solarc makes an amazing product. What you're looking on the left-hand side, there are batteries actually in, they have the wall brackets, and then you're seeing them all paralleled up on those terminal blocks. We got 2 Solarcs sitting there. And if you notice down in the, still looking at the left-hand picture, but down in the bottom right corner, that's a propane heater. And you can see the little yellow gas line that's feeding that propane heater that's going to heat this entire room. So it's another way to keep the room warm as well. You know, it definitely account for that propane use. Top right, I love those pole mounted units. They're tilted pretty low. That's some pretty large pole mounts compared to some of those other ones, and you can still see the snow in the back.
So
Great
Daniel,
system.
one more point to make about keeping your batteries in a warm environment, right, in a warmer temperature is, yeah, you do have to spend some money on that propane heat, but you also gain efficiency. The batteries are most efficient, deliver the most amount of energy, and have the least internal resistance in that 30 to 40 Celsius range. You get above 40 Celsius and you can risk under a rapid discharge of the battery getting to too high of temperatures. But you keep those batteries 70 to 80 degrees Fahrenheit, 30 to 40 Celsius, and you're looking at more efficient batteries, right? Batteries that operate better, that reduce the amount of loss that you get in the charging and the discharging cycles. So there is a value in keeping your batteries in a temperature controlled environment from a electrical perspective as well.
Yeah, great point. Otherwise, you'd have to add additional batteries to make up for that potential loss, right? So,
exactly.
So you're making it up. Great point, Nathan. Thank you. Here's the food truck. I really like the way that they've kind of secured the batteries in such a way that's not going to be moving around or as like Outback equipment, Outback inverter right there, Outback charge, Midnight solar charge controller. It looks like there. Some solar panels up on the roof. I kind of like the way the solar panels are on this track system that are allow it to kind of to slide out and offer additional kind of surface area when the food truck is parked. A lot of times,
keep in mind, Daniel, if we do have customers that are planning to put batteries into a mobile environment, make sure that you try to insulate from vibration as well. So putting a foam pad, for instance, underneath the batteries can dampen those vibrations and prevent that from being transmitted into the cell pack, etc.
Yeah, exactly. Another, and I don't mean to pick this picture apart, but I'd also rather see the bus bars leveraged here rather than this daisy chain as well. What I do like is I can see that their positive home run is over here on the left-hand side, and the negative home run on this battery bank is over on the right-hand side. So we're kind of feeding the bank from opposite ends, and that's the best practice for any battery, is that we're not having one battery work harder than the others, and we're kind of splitting that on different sides. So great point there, Nathan. Heat, right? This is another. I like my pole mounts, right? I got a lot of pictures of pole mounts in this presentation. I'm realizing. But again, if you look on the picture on the right, this is an insulated container here with a bunch of charge controllers, and it looks like some Outback radians as well. We do have an in-house testing facility. This is down in Oxnard, California. This is right across the street from where the assembly of the battery takes place. And it allows us to do a number of lab-based tests to subject these systems to some real-world applications. Additionally, in order to get these batteries certified to ship air cargo ship, is that we have to get what's known as UN 38.3, and essentially what they do is they replicate what it's like to be in the cargo hold of an aircraft. And what is it like to be in a cargo hold of an aircraft? Well, it's probably cold. There's thermal cycling. It's probably very low pressure, so they store it at low pressure, and then they vibrate it as well. Then they drop it, right? Who knows what happens to our luggage when it's on an aircraft? I mean, we've all looked out the window. So what they do is they put it through this battery test, and essentially if it doesn't leak, it doesn't catch fire or explode, you can get the certification. I'm going to be running pretty quickly here, everyone, because I recognize we have about 7 minutes left, and I want to leave a little time for questions as well. And we mentioned this earlier, we do have to obtain UL listings for these batteries in order for your jurisdiction to allow you to pull a permit. A UL 1642 is on the cell level, 1973 is on the battery module level, and then 9540 is on the system level. And that 9540A kind of informs what's called out in the UL 9540. Similar to that UN 38.3, they subject the battery to kind of adverse conditions and then watch what happens and report back as well. definitely not going to walk you through on everything on this, but the large scale fire testing, which we were talking about earlier, which we're so proud of our results, available on our website, simpliphipower.com, essentially forces the cells, heats the cells to such an extent that artificially induces heat into the cells to force it into a propagation event where it spreads to an adjacent non-heated cell, and then watch what happens. And really, we were able to show that not a lot happens, and we didn't have that kind of explosion or fire that's kind of you've seen.
In fact,
yeah,
Daniel, our cells, our battery modules that compose to these cells, which are artificially heated until they are go through an off-gassing event, and the adjacent ones do so. So the artificial heating of the cells causes that to happen, and our batteries, these thermal events self-extinguish. And that's a distinguishing factor for our batteries, right? We pride ourselves on having safe energy storage systems for our customers.
Yeah, and I would always bring that up at the kitchen table, is talk about how safety is paramount. This is somebody's home, this is somebody's business, and the last thing we want to do is bolt something onto the side of their house or in their garage that has this potential for kind of thermal runaway, which is when it, instead of it kind of self-extinguishing, the cell that kind of got heated causes the next cell to get heated, which causes the next cell to get heated, and then you get this kind of runaway event happening. I'm showing this picture here because it's an insulated battery cabinet, but it's also demonstrating that what we want to see, though, is the way you wire our batteries are always in parallel, never in series. And what we like to see is the batteries, conductors of the same gauge and the same length, go into a common terminal block or bus bar, if you will. And you can see some of these, this cable is kind of unnecessarily long. It's actually not unnecessary. It's the correct length because all of these cables are the same length. We do have bus bars that I had kind of alluded to a little bit earlier as well.
And it's important to have those battery cables the same length, Daniel, to keep those batteries balanced, right?
Yeah, so we don't get some batteries working harder than others. And so you can get resistance in the wires. We can play with the gauge. If you do have some wires that are longer, you could say increase the gauge of that wire, but that's something we don't want to get too deep into when we have sales application engineers. The idea is that the resistance of all of the cables are equal, so each battery is working just the same. Market drivers, home is a haven, that came out of the pandemic. Existing infrastructure needs investment. What I mean by that is that, you know, the power company probably is doing a good job at upkeeping the power lines in your neighborhood. At least I hope they are. But as we're moving into this all-electric kind of future with the electrification of our heating of our homes, of our transportation, we really need to leverage distributed assets, batteries on homes, or maybe even on local utilities to help us kind of transition into the next future, the next phase of what our electrical grid is going to look like. Climate-related disasters, ice storms, hurricanes, earthquakes. I already kind of talked about electrification of everything. We already talked about clean energy subsidies. Desire, DSIRE, USA.org, I think you said, Nathan, is going to show you the state incentives. There's new IRA opportunities, especially with some of those adders as well.
Yeah, Daniel, unfortunately, I don't have a way to type that into the chat without somebody asking a question, but the website is D and then SIREUSA.org, and that will list the incentives that are available within the US.
Yeah, I think that's the University of North Carolina, I want to say. I'm not sure exactly, but it was through a university that it's a nonprofit. So just put in your zip code, it pops up. It pops up your interconnection policies. It pops up if there's an EV charger rebate, right? So don't just go out to someone's house and put in batteries or solar. Put in an EV charger. Put in a heat pump. Be that whole home solutions provider to help them electrify their home, get them off of that natural gas or propane tank that they may have, and really see them to the future. And a lot of opportunity, and that website will help you leverage that. A lot of people have solar and they didn't get batteries. A lot of people that have solar now want batteries. Using our energy storage system, we can now AC couple in some of those solutions and work them. We already talked about generator optimizations, but we also offer the ability for off-grid. We make energy storage systems. What you're seeing up top is our inverter. energy track in our 4.98 kilowatt hour battery that is outdoor rated. You're seeing some of our generators down at the bottom. Really, what I kind of want to call out on this slide is our amazing tech support and our training as well, which you're here today. So if you have a problem, you can call us. Somebody here in the United States is going to pick up the phone and help you out. I've been out there in the field, in the rain, on the side of a house, calling a company's tech support, and I understand how important it is to have good tech support, and that's somewhere where we absolutely shine. Large scale commercial team, we didn't really talk about commercial today, but that might be a future talk. We have high voltage solutions, containers full of these batteries that can be leveraged on larger scale systems, and really the history of Briggs standing behind us. Already mentioned the energy storage system. One thing I don't want to skip over is the Energy Track, the app. We have a great, robust app, and all that data is housed in the United States as well. There's the battery lineup. The far battery on the left is the Phi battery. Remember, the one that doesn't have closed loop communications, that is great to pair with other people's equipment. The two communicating batteries in the middle, and finally the inverter on the right-hand side. As we're wrapping up, please put in any questions you may have into the chat. I know we're running out of time, so I'm going to keep it going kind of quick here. But really, we're here to leverage not only our energy storage systems, but our generators. You can combine the two and have them complement each other. We have what's known as our NG Max line of power protect generators. What that means is that if somebody goes out and sells you an 18K generator, that's 18K on propane. But when you run an 18K generator on natural gas, you're not getting 18K out of it. So we're really able to have what's known as NG Max. Our 18K generator is going to produce 18,000 watts, whether it's on propane or natural gas, recognizing that almost 70% of the people in the country have natural gas. We really shine, and when it comes to warranty, really where I see it shining is everyone's going to pay for the parts and the components, but who's going to pay for the time and the labor and the mileage on the van, right? You still got to pay the gas, the tires, the insurance on the van. So we really beat a lot of our competition on that. One thing we've been talking a little bit about is how to sell systems and make it less complicated to the homeowners. Instead of talking to kilowatt hours and watts and days of autonomy, just sell them hours of backup. And we're not going to go too deep into this, but when you're looking at an outage, a typical outage in the United States, most of these outages are a lot shorter than you might imagine, like 2 hours or so. These are the nuisance outages where somebody crashed their car into the power pole down the street, and it's going to take a few hours for the power to come back on in the neighborhood. So excluding major events, some of these packages will work just fine. And this is without solar, right? If you have solar to recharge this battery, you could essentially give that home a microgrid. We did make some assumptions on how much power somebody consumes during an outage, and you can kind of see it down on the right, and we'll jump into that more in detail at a future event, future talk. If you are an installer, I invite you to apply for our IQ installer program, the Elite Installer Qualification Program. We'll put you on the maps. We'll send you some more swag than you guys are already getting. We have some rebates available. It's a way to help promote your business. If somebody's in your area looking to have our batteries installed, we'll send them your way. Keep in mind, that poweracademy.com, a great resource, and we do have some promos. Nathan, would you quickly walk us through some of these promos?
Yeah, sure, Daniel. Well, first off, with our new ESS system, if you have not installed one of these, you are eligible for a $1,000 rebate on your purchase of your first ESS system, and this is good through the end of the year. We additionally have a $75 rebate on every battery purchased as an authorized installer. So sign up for authorized installer program, and you get another $75 discount through the end of the year. And then a $100 rebate on every battery purchase as an Elite IQ installer. Also, if you buy a Boss 6 cabinet and 5 batteries to go in that Boss 6 cabinet, we're giving away a free battery with that Boss 6 cabinet. So that's a $2,000 savings right there. Free conduit box as well if you are purchasing those outdoor rated wall mount waterproof batteries. So we're giving that free conduit box away. That conduit box goes over top of those batteries. It's waterproofed and it allows for easy connections. So again,
Nathan.
one more thing to mention is we are approved as a California manufacturer for that SGIP. So if you are doing a project within California, you can get an extra 20% rebate on your full system for those, on your Amplify and Phi batteries for those costs. And soon we'll have that for the larger 4.9 SimpliPhi as well. That's for California residents or California projects.
Thank you, Nathan. Really quickly is that we really want to make these trainings better for everybody who's attending. And one way we can make it better for you, and I know nobody likes doing a survey, but they really do help us. So please scan this QR code. I believe you're also going to get an email after this webinar is over. Just take the time to fill out the survey. It's going to help us make these trainings better for you. Scan this QR code and look for that survey. We'd really appreciate your feedback as well. If you're looking for the NABCEP, here it is, training@simpliphipower.com, training@simpliphipower.com. Email us your name, full first and last name, spell it out for us, and we'll go ahead and issue you these NABCEP credits, the continuing education credits. The kind of scan for the survey is here as well. But really, thank you guys, everyone, for attending. Keep in mind, not next week, but the following week, we're going to have Off-Grid Living with SimpliPhiPower.com. I wish you all a happy holidays. And Nathan, do we want to mention the winners here, or just call out who's at the highest altitude and who had the coldest temperature?
I forgot the names. I know Amanda got one. She was also the only person that gave us an altitude here. Our friend in Santa Cruz, unfortunately, didn't get cold temperatures or high altitude. But I will. I've emailed those people. I've asked those people to email us, and we'll go ahead and get those sweatshirts out to them.
Great. Thank you, everyone,
Thanks,
for
Daniel.
joining us, and we'll see you guys next time.
Bye, everyone. Thank you.
Bye.